With this lesson, we are going to discuss the commutative and associative properties. Now, these are things that I'm sure you already know are true. You've been using them in math for quite a while. Our focus here isn't so much on just the number part, but it's in recognizing which one it is. So mostly this is a vocabulary lesson. Do you know what the commutative property and the associative property each are? Our objectives are to be able to distinguish between the two. When we use them, you should be able to look at it and say, here they're using the commutative property, over there they're using the associative property. And additionally, we want to be able to pick and choose when we use them so that we can add or subtract a little bit more easily, just to make problems easier for us. Before we launch into the lesson, we want to make sure that you can add numbers to create zeros. For instance, you would recognize 13 plus 17 would put together 3 and 7, which make a 0 for 30. You can also multiply to get zeros. 12 times 5 sets it up so that 2 times 5 is 10, and that 10 leads us towards a 0 with our answer with 60. We'll use those as strategies. So once again, I want to emphasize there are two properties. You've been using them for a long time, and the focus of this lesson is so that you can recognize and use them. Here's the first one. The commutative property says you can flip around addition or multiplication. For instance, 3 plus 5 would give you 8. And if you flip it around so that it's 5 and 3, you get the same answer of 8. 2 times 7 is 14. If you flip it around to 7 times 2, it's still 14. That's the commutative property. We can switch the locations of the numbers, and it doesn't change the number result afterward. Subtraction does not work. For instance, if we tried to do something like 4 subtract 2, that would be a positive 2. And if you switched it around, it would wind up being a negative answer. So subtraction, there is no commutative property for subtraction. It does not work. Similarly, there is no commutative property for division. 4 divided by 2 would equal 2, but if we flip it around, we get 0.5, not the same number. The commutative property only works for adding and multiplying, not subtracting, not dividing. Well, where this gets helpful is that we can flip numbers around to put together the easier ones. In particular, when we're looking at multiplying these numbers, here we have 7 plus, I said multiplying, I'm sorry. If we're going to add numbers, we've got 7 plus 21 plus 3. We would want to recognize that 7 and 3 are numbers that are really easy to add together. That would give us 10. And adding the number 10 is also really easy. The commutative property then comes into play where it's just a strategy to make problems easier. If we flip around these two numbers, it then puts the easy numbers together for 7 and 3. That would lead us to 21 plus 10, and 21 plus 10 gets us our answer of 31. It's easier to do it this way instead of just going straight forward. 7, I wanted to color here in red, 7 plus 21. Well, they're not even lined up correctly. Even if you flip them and wanted to do 21 plus 7, that gives you 28. And then we'd have to still add on 3, which gives us 31. So we can still do it. We can still get the answers without using the commutative property. It's just longer. It's more work for us. And we're trying to find the easier ways to do it. Similarly, we would have the commutative property for multiplication. If we were to go through it directly, we would have 5 times, oh, can't really see that too well. 5 times 3, okay, that's 15. Quick, in your head, what's 15 times 12? See, it's not quite so easy there. Now, we could still work it out, we could still get our answer, but it's not as easy. Instead, if we apply the commutative property, just switch around the 3 and the 5, or if we wanted to, we could apply the commutative property to switch around the 3 and the 12. If we switch those around, we've got 5 times 12 times 3. And now we can actually do them in their stages. What's 5 times 12? And 60 times 3? Well, this is why we wanted to create the zeros. With the zeros at the end, we only have to do 6 times 3. 6 times 3 is 18, and we'll put the 0 back on. We've got 180 as you told us, Jack. Well, frankly, which is easier to do? 60 times 3 or 15 times 12? I think we'd agree that 60 times 3 is the easier way. This is why we have the commutative property. We want to make them easier. All right, so just to reemphasize, as you asked your question, Michelle, the commutative property only works for addition and multiplication. It does not work for subtraction. It does not work for dividing. We can't flip those ones around. All right, the second property we're discussing is the associative property. And remember, we do expect you will be able to recognize when this is being used, and we expect that you will be able to pick and choose when you want to use it. The associative property lets you do things out of order, and it still won't change the answer. But you can only use it out of order in a very particular context. For instance, we know that the order of operation tells us that if we have 4 plus 15 plus 5, following the order of operations, we are supposed to do the one on the left first. 4 plus 5 would be 9, and 9 plus 15 equals 24. Well, that's still a problem where we had to add 9 and 15 in our heads. And, some people have got a skill where that's not a problem. It's a little bit harder for others. The associative property, though, lets us say, because it's only addition, there's no subtraction, no mixed stuff, only addition is going on here. Instead, we could do the right-hand set against the order of operations. Order of operations tells us do the one that's on the left first, or the associative says, in this context, when it's only adding, it's okay to do the one on the right. What's 5 plus 15? And 4 plus 20 is a whole lot easier to add. But we'll notice then, we're still getting the same answers. The associative property also works with multiplication. We can have pieces where the order of operation tells us to do 7 times 5 first. Of course, that's 35. And in your head, what's 35 times 8? A little bit harder to see. All right? You hear the answer of 280, but you don't sound very confident. All right? Here's where we can have pieces that are a little bit nicer. Because it's all multiplication, like we had with the addition, we are allowed to do the one on the right first. It's 5 times 8. And then 40 times 7 is a whole lot easier to multiply by, because we know we can ignore the 0, and we'll just put it back on at the end. 7 times 4 is 28. And then because we had a 0, it needs to get reattached, and we do have our answer. This is why we mentioned that one of our pieces we want to try to find the zeros. When we reorganize pieces, can we find zeros to make it easier to do? Because adding by 0 is easy, multiplying by 0 is easy. So we want to try to create and find those zeros. So where would you want to put the parentheses in here? Where would you want to put the pieces to make it easier? Keep in mind that we already have the associative properties, we already have the commutative properties, so we can flip numbers around if we want. Right? Recognizing the numbers, 7 and 3 are going to be the easier ones. We want to put those together. So we'll start by using the commutative property and flip them. Commutative property flips. Then the associative property groups them. (21 plus 10 is 31. We'll put the easy numbers together. Look at the second one. Do you see numbers that when you multiply them will create a 0? No, they'll create something like 10, 20, 30, 40, 50. 5 and 12. Multiplying by 5 and 12 will create the 0. Recognizing that, those are the ones that we want to go together. Putting those together makes the problem easier. So what do we need to flip? What do we need to shift? What needs to happen? Okay? We're saying flip the 3 and the 12 with commutative. 5 times 12 times 3. 5 times 12. 60 times 3. 180. And we've got it. Alright, so far. Alright, some other things that we did want to emphasize with the associative property. Again, this only works for addition by itself. It only works for multiplication by itself. If you had something like if you had subtraction, where you shifted the parentheses, this will not work for subtracting. For instance here, 5 minus 3 is 2. 13 subtract 2 is 11. What if we shift the parentheses? 13 subtract 5 is 8. And 8 subtract 3 is 5. There is no associative property for subtraction. We will encounter the same problem for division. There is no associative property for division, and it likewise will not work if you have a mixture of adding and subtracting. You cannot guarantee by shifting stuff over that it'll work. Sometimes that will, sometimes it won't. You need to remember associative property applies only to plain addition by itself and plain multiplication by itself. So, all right, identify the property, then find the sum or product. We get to pick and choose which side to do, left or right, because we know they'll be the same. Looking at it, we know the commutative property flips numbers, associative property moves parentheses. Which one happened? Did we flip numbers or did we move parentheses? Because we moved parentheses, this is the associative property of multiplication. Because we moved parentheses around multiplication. Picking the side that we want to do, Rochelle, you said the right-hand side is easier. So let's do the right-hand side. 6 times 5, 30. We're done. What about here? Is this the commutative or the associative? That is the commutative property because we flipped the numbers. And we flipped addition, so it's the commutative property of addition. And I think 6 plus 3 is pretty easy to get, so we're just going to say 6 plus 3 is 9. Now we can also use these properties combined to do harder math in our heads. For instance, 97 plus 28 plus 3 plus 2. When we look at these, we should recognize that 97 and 3 are easy to put together. We should recognize that 28 and 2 are easy to put together. So we want the 97 and the 3 together. We want the 28 and the 2 together. The obvious choice then is to flip the 28 and the 3. So our first step, 97 plus 3 plus 28 plus 2. What property did we just use? So off on the side, we will write down the commutative property of addition. Since we flipped addition, we used commutative of addition. There we go. Okay, so here, 97 plus 3 is 100, plus 28 plus 2. And there, all we did was add. Officially, there's another property called closure. We don't need to know the name of closure, but that's what we were doing here. Well, now what? What's the next thing we were doing? The next piece we wanted to do was add 28 and 2. So we need to put these parentheses in to show these are the numbers that we're adding. And that's where we use the associative property of addition. So 100 plus 30, and all we did was add, giving us a final answer of 130, where all we did was add. And I know it seems kind of silly where they're like, use mental math, and doesn't mental math mean you did it all in your head and then you didn't actually write anything down? Yeah, it does, but this isn't a problem that says we want you to use mental math. It's saying, I want you to show me what you would do in your head when you do use mental math. This is a process that you'll go through very, very quickly. When you look at the numbers, you should quickly identify 97 and 3, easy, that's 100. 28 and 2, easy, that's 30. Cool, 100 plus 30 is 130. It shouldn't take very long. Writing it out, though, shows that you recognize all the processes, all those quick steps, and you're slowing yourself down to show us that you've got the thought process that puts it all together. So let's do the same process. Which numbers could you multiply and create something that's really easy? Recognizing that 4 times 25 is pretty easy. Those are numbers we want together. And so if we're going to do that, that could also put 15 and 6 together. So our goal then is to flip the 4 and the 15. 6 times 15 times 4 times 25. And that was the commutative property. Okay. Now the point was raised. To try to save ourselves a little bit of time, can't we simply say 6 times 15 and 4 times 25? Take the two pieces of the associative property and put them down in one line instead of two? Yeah. You're still explaining what we're doing. We're putting those in. And from there, when we actually go through and multiply, 6 times 15, not quite as easy as some of the other ones. And so if you need to go off to the side and do some scratch work, it's not a problem. It's not like everything can be done mentally, but we'd still get 90. 4 times 25 is still straightforward. It's 100. And then 90 times 100, multiplied by 100 just means you've got to tack on some more zeros. So 90 with 2 more zeros, we get 9,000. And we're done. And that's it. These are all the pieces that you needed to be able to do. With these problems, we are both recognizing and using our properties. That's, of course, what we were trying to do. Recognize the commutative property and use it. Recognize the associative property and use it.